Good morning, students. In this class, we will see about the evaluation of language models. Till now, we have discussed about so many language models. That is the N-gram language models, then this noisy channel language model. So many language models we have discussed. The main purpose of the language model is to discuss about the prediction or the spell correction. Mainly, the language models are used in the NLP to correct the spelling as well as to predict the next word. Like in WhatsApp and Google, we are predicting the next word based on the probability of the words in the corpus. Corpus means set of words or a collection of words. From that, we can predict the next word. For example, for your if you are using your Gmail means if you are using a Google means based on your account is linked in the particular Google, and what all are the frequently used word by you, that will be displayed to you. If I am using that for myself, what is the commonly used word for next to the particular word, that will be displayed. For example, if I am using computer and next word will be automatically computer science. Most of the time I'll type computer science and engineering. So it will look like that. Similarly, if I am typing associate, automatically professor will be displayed that because I am using that word frequently. So the probability can be calculated based on the frequency of use of the particular word, and hence that is mapped. To predict the next word from the existing things, we use this N-gram model, noisy channel model, and so many language models. After this development of language models, if you want to evaluate, if you develop any model, we should evaluate that model. How can you evaluate the model? The developed model can be evaluated by using two techniques. First one is the extrinsic technique, and another one is the intrinsic technique. Extrinsic as well as the intrinsic technique. Extrinsic technique means here, if you want to check the performance of two different models, your entire system can be checked with two different models. You should run the tool. If you develop two tools for the prediction, then you run the tool over a same kind of data set or same kind of corpus, and you will check the performance or the accurate of the tool. So how will you check the accurate of the tool? How it correct the misspelling, or how it corrects the errors, or how it corrects the grammar. Based on that, you will identify the accuracy of both tools. If A and B are two tools are evaluated, and tools are adopted in your system, and the accuracy of both tools are identified. From that, if the accuracy is high, that tool is considered as the better tool. But the drawback of this one is it's time consuming as well as very expensive. If your data is a large data, if you are running your tool in a very large system, then it take more time as well as it may take 1 week or 1 day or etc. And it's very expensive to execute that particular thing. Instead of that, we can use for the intrinsic evaluation. Intrinsic evaluation, we are using certain things. For example, in the machine learning model means we can find the accuracy of the model and the F-score of the model, sensitivity, specificity, everything can be calculated now. Like that, in the NLP also, we can use some evaluation metrics for intrinsic evaluation. And here we use some test sentences as well as the trained sentences. Always for any evaluation, we need training as well as the testing. No? Within the known data, you take the trained sentences as well as the test sentences. Train your model with the trained sentence and check whether it predicts the test sentence in a correct manner. If it is predicting it in a correct manner, then your model is the good model. For this prediction, we need some of the measures, and that will be discussed in the next slide. So the first one is the perplexity. Perplexity is one of the measures used to evaluate your system. Perplexity can be defined as, we know that how to find the probability of a bigram probability, unigram probability, and the n-gram probability of given words. Perplexity is also a measure of the probability. Here, if you want to find the perplexity, then perplexity of the word 1, word 2, etc. wn. If n words are there in your sentences, then you should find the perplexity by using the formula P of W1, W2, etc. Wn, the whole power minus 1 by n. That is the inverse of your number of words. If number of words in your corpus is n, then the perplexity can be calculated by using root nth root of 1 by P of W1, W2, etc. Wn, probability of the particular thing. Here we use the chain rule to find the probability of next data. In the corpus, there are so many sentences. So for each and every sentence, first you find the perplexity, combine all the things, add all the probabilities to get the final probability. In the final thing, if the perplexity is less, means the probability of the word is high. That is, your prediction is high. The higher the condition probability of the word sequence, the lower the perplexity. So less value of perplexity is good for any corpus. If perplexity is low, means then the probability of finding the next word is, that is the correct prediction, is high. And another one method used for this evaluation is the smoothing technique. You know that what do you mean by smoothing? In some situation, there is a possibility of zero probability. Zero probability means that sentence is not at all available in the corpus. It means like that. But in the entire data, if the NLP tool is applicable for the small set of data as well as the large set of data, if it is a website, then definitely there will be a maximum likelihood sentences. But if you are selecting only few sentences, 10 or 12 sentences for test case, there may be a possibility of zero occurrence of the probabilities, possibility of zero occurrence. In that situation, that is the wrong answer. Here, if you are getting this finding the accuracy, you may get the probability equal to 0. If the probability is equal to 0, means that's wrong. Anyway, there is a possibility of that kind of sentence when you are comparing with the entire corpus. So in this situation, what can you do? That is what available in this concept, smoothing. For example, you are using here, this is example for smoothing. In the smoothing, consider this waveform. So here, when you are seeing this one, you can't predict this. This is looking like a Christmas tree. You can't predict what is that. But if you want to convert, if you want to find the area of this one, what can you apply? This is not possible. So we can use the smoothing technique. We will convert it into a nearer thing. No? We will convert it into a nearer point and smooth the curve. When you are smoothing the curve, this is the curve, right? With some error, this is the curve. So what is this curve? This is the normalization curve, or it may be a sine wave. It may be either a sine wave or normal distribution curve. From that, you can easily identify the properties. To find the properties of such defined curve is easy compared to the undefined data point. Same manner in the smoothing, if zero probability is there, you should not take the probability as zero. Instead, nearer probabilities may be taken into account. For taking such probabilities, we use some set techniques. The first one, this is the need for the smoothing. For example, consider this example here. Some test training sentences are given. What are the training sentences? Cat stays rat, cats meow, rat chatter, cat stays birds, rat sleep. Some training sentences are given. From the training sentence, we are going to find the probability of the next sentence. Here, the next sentence is cat sleep. We are going to find the probability cat sleep. When you find the probability, how to find the probability? Consider the bigram probability. Here you should include the start symbol as well as the stop symbol. So it can be written as S is the start symbol, cats, sleeps, followed by the stop symbol. First, you should include this one. Then you are going to find the probability from the test data as well as the trained data. Consider the probability of finding this one. How many words are there? Take 2 at a time because we are considering the bigram probability. So probability of cats by, probability of cats by, probability of dollar into probability of sleep by cats into probability of final symbol divided by sleep. This is the way to find the probability. We know that the formula to calculate the probability is, what is the formula of bigram? Probability equal to word of, okay, count of, probability equal to count of W2, W1 divided by W1. This is the way you should find the probability. So to find the count means, how you find the count? First, to find the probability of cats by dollar equal to count of this initial symbol. Here also you should include initial symbol and the final symbol in each and every point. If you include the initial symbol and final symbol, for the test case, you get it from the training set. The training set, how many initial symbols are there, 1, 2, 3, 4, 5. So 5 initial symbols are there. Then next you find the word dollar cats. Okay, first symbols, dollar cats. Combine these two. Dollar cats, W1, W2. So dollar cat means where it is only here dollar cats is there, here dollar cats, $3 cats. So count of probability of 3 by 5 into probability of sleep by cats. If you find the probability of sleep by cats, first write the count of cats. What is the count of cats? 1, 2, and 3. 3 cats are there. We are going to take it from the training set. So 3 cats are there. Then cat sleep. How many cat sleeps are there? Nothing is there in the training set. So 0 into probability of n symbol by sleep means first count the number of sleep. How many sleep is there? Only 1 sleep is there. And sleep end means sleep end. Here there is sleep end symbol. So sleep end symbol is 1, 1 by 1. 1 by 1 is 1. 3 by 5 into 0 into 1 by 1. Here the probability is equal to 0. Because 0 by 3 is 0. It means there is no symbol called as cat sleeps. There is no symbol in the training set cat sleep. So we can't find the next one. Cat sleeps on bed, cat sleeps on floor. We can't find that one. Here the probability is 0. But it is not possible. When you see this, at least in one sentence, it should be specified in the entire corpus. Here we have selected little amount of data or minimum number of sentences for this testing as well as training. This is the case. Here there is occurrence of 0 probability. In this case, if the answer is 0, we can't define which one can be selected next. Probability should not be 0. To avoid this one, we are going for the smoothing techniques. There are so many smoothing techniques. We'll discuss only few smoothing techniques. First one is the Laplace smoothing technique. The Laplace smoothing technique. Here, for avoiding the 0 probability in each and every probability calculation, probability of Wi equal to, for calculating this one, in each and every calculation, you should add 1, okay, amount 1, divided by, in the numerator, you should add 1, and the denominator, add the total number of words. That's the one and only difference in this probability test. Okay, here to find the probability, add 1 in each and every probability, divided by, add the entire word count in the denominator. That means the previous slide, you see here the probability is 3 by 5, 0 by 3, and 1 by 1. 3 by 5, the probabilities are 3 by 5 into 0 by 0 by 3 into 1 by 1. 0 by 3 into 1 by 1. So only the value is 0. To avoid this one, in each and everything, you should add 1 in the numerator and the entire words in the denominator. How many words are there in the denominator? 1, 2, 3, 4. The total number of words, including start and the stop symbol, the number of words equal to 4. So we should add 4 in all the denominator, and the numerator and the Laplace method, add 1 here and add 4 here. So here also add 1 and add 4. Here also add 1 and add 4. So 4 by 9 into, instead of 0, it becomes 1 by 7 into 2 by 5. Calculate the value, it will give the probability. Based on that, the probability is calculated, and which word is having the higher probability is taken from the corpus set. That is given here. Count of Wn minus 1, Wn plus 1 is added there, and count of Wn minus 1 plus V. V means entire word, entire word in the test sentence. So this is the way to find the probability for identifying the next sentence. Same manner, the next technique is, here we normalize. Add 1 means we are normalizing the value. The next one is the add case smoothing. In the add case smoothing, instead of 1, we will add either a fraction of amount. Depends upon the word, we will find the probability, or we will find the fraction amount, and that fraction is added, means that is called as add case smoothing. Instead of Laplace means add 1. Case smoothing means add the constant amount, either it may be 1 or 0.1. It may vary from 0 to 1. Add that amount and the numerator and the denominator also instead of b, kb is added. This is the one and only difference in the add k smoothing. This technique is mainly to avoid the zeroth probability, even though if it is a small data set. And the next technique is the back off and interpolation technique. The back off and interpolation techniques, the back off, instead of adding 1 or the fraction value, we can find the probability. If the probability of the particular thing is 0, then find the bigram probability, unigram probability, trigram probability, and add all these things to get the final answer. That is what it's called as back off. Which one is the similar one? That is find, you are doing the bigram. Bigram probability means you are taking 2 words at a time. In that, in one probability 0, then there is some confusion. No, in that situation, take a unigram probability or a trigram probability, then it will give some value. That is what called as back off. For example, here cat sleeps, na? So here 2 words, the probability 0 means check the next word also, or check the previous word. So one day, or black cat sleep. So go and check the black cat sleep. Instead of the cat sleep, go and check black cat, or go and check this black cat sleep or black cat at a time. So based on that one also you can predict some words. If you know the previous word or the next word, then also you can predict. So you should take the next level probability or the previous level probability to identify the current prediction, means that is called as the back off. Interpolation means if you don't know the probability, if you are getting again 0 as the probability, you first take the trigram probability, then bigram probability and the unigram probability up to the n-gram probability. Add all that probabilities and divided by n, you will get interpolation. We know that interpolation, no? If you know the value of x1 and x2, how do you interpolate these two? x1 plus x2 by 2. That is nothing but the average. Here you are finding the average. That is what the interpolation. Next, previous divided by number of things, you will find the interpolation probability. These are the techniques used to find. These are the some evaluation techniques used to find the next word, next prediction. With this one, you'll identify whether the word can be predicted in a correct manner or not. These techniques are used for the language model to evaluate the models, and these techniques are called as the intrinsic techniques. And extrinsic technique means in the entire tool is used in a single set of corpus, and the evaluated model A and B is evaluated based on the accuracy, and from that you will select one of the tool. So this is the, by using this Laplace, back off, interpolation, K, add K, these all are the techniques called as the intrinsic techniques. That is inner manner. Inside that tool, you can use these techniques to identify whether this is a good tool or not. Thank you.